Hey guys, Miss Cochran here, and we're looking at our page 7 from our packet, and we did the odds for warm-up. And what did you guys think about number 1? What did y'all get? X is 3. So that was the answer for that one. What did you guys think about number 3? What? X equals, did I hear negative 1/3? Okay, it should have been negative 1/3. What about number 5? X is a, actually it's M, but I've already wrote X. So M is a negative 1/2. Okay, good. And what is our answer for letter K in problem 7? 3/2. Okay. Are there any of these 4 problems that you'd like me to work the steps out? Yes. Number 7? Okay. If you'll take a look at number 7, and I think I may write it a little bit larger on regular notebook paper so that you guys can see it even a little bit better. This is us doing problem number 7. Okay. Just as a reminder of our lesson we did yesterday. So on this particular problem, and let me get that situated. There we go. Because this has a multiply, I would add the exponents. I would leave it with one base, and a 3k with a 5k is 8k. A negative 1 with a negative 7 is a negative 8 when I add that up. Okay. I still have the 16 on the other side of the problem, and we were taught that we could try to make the bases look alike. So is there a power of 2 that is the answer 16? Okay, I hear 2 to the 4th. Yes, 2 to the 4th is the same as 16, so we can convert that one. I'll just rewrite this side of the problem. And now that my 2's match, we can just solve the exponents. So we can just say 8k minus 8 equals 4. And we can add our 8 over, which 4 and 8 gives us the answer 12 on that side. On the other side, we have our 8k. We could then divide by 8. And we could either put it in our calculator or reduce the fraction. If we reduce the fraction, 4 goes into 8 and 4 goes into 12. So we could divide by 4s to reduce the fraction. 4 goes into 12 3 times, and 4 goes into 8 2 times. Or if you had just typed it in your calculator, you could have gotten the answer 1.5. I'm really good with either one of those answers. I won't mark any of it wrong because they're correct. Questions on number 7? Okay, nothing else on that one. Did anybody want me to work number 5 out? Yes, okay. I know earlier today and in different classes, 5 they had asked to see. So let me write number 5. Okay, and when we look at number 5, one thing that I start out noticing is this fraction. And I know I can move this back to the numerator by putting it to a negative 1 exponent. That kind of shoots it back on top. And then if you start looking, can we make 27 a base of 3? Like a power of 3? Isn't it 3 to the 3rd? Yeah. So our 27 can be 3 to the 3rd. Then that negative 1 is still kind of floating up top. I'm just rewriting our problem. Okay, so it can be neatly written. Now, remember when they're next door to each other, 2 exponents like this, and there's only a parenthesis separating them that you multiply? So 3 times negative 1 is a negative 3. And then, because my base 3's match, we can equal the exponents. So if we simply just equal our negative 3 equals our 4m minus 1 and solve this equation, we'll have our answer. So what step do we need to do first in solving our equation? We would get rid of the minus 1, so we do that by how? Adding it over. So we're going to add 1, but when we add 1 to a negative 3, that leaves us negative 2. Our 4m can be brought down. How do I get rid of that 4? We're going to divide by the 4. When we divide by the 4, this is where when you reduce this, you get a negative 1/2. And that is the answer to number 5. Any other questions on page 7, those odd problems? Okay. Then I'd like you guys to turn to your page 9. And on page 9, the beginning of this says, what is a logarithm? It says a log is another way of writing exponents. It's just a different way to write it. I'd like to refer back to an old concept for just a minute, the square root 25. Didn't we learn another way to write that? Didn't we write it with a exponent and say it was 25 to the, do y'all remember? This has a little understood 2, that has a 1. It was 25 to the 1/2. Yeah. And these meant the exact same thing. They were just written differently. One was written as a radical sign and one was written as an exponent. But they meant the same math. And if you put them in the calculator, they give you 5. Both of them do. No matter what, they were the same. That's what they're going to be talking about, but we're doing it with something different. They're saying that it's just another way to write exponents. Now, to get us started, they give you the logarithmic form. They say log with the base b. Notice how they say it, how to read it right here. It says log base b of a is x. You can interchange is and equals. In math, is the same as equals. So log base b of a equals x. This can be rewritten as an exponential form, and it would be, remember how I talked about, like in our problems, let me flash back for a minute. In these problems over here, that the 9s were the base, and over here the 2s were the base. Right here, the 8 is the base. The number that has the exponent is the base, right? Well, same thing applies right here. The base here, the little base number for the log, is the base number when you rewrite it as an exponent form. The answer to the log is always the exponent. So x, see how this log equals x? X in that little statement is the exponent because logs equal the exponent. Let's look at a few of these, okay? I'm going to try blowing this page up just a little bit more so you can see the problems a little better. We're going to do the odds right now together in class, and all they want you to do in this problem is rewrite it. So remember what I said about the answer to the log? It is the exponent. So this problem would be rewritten as 3 to the 2 power is 9. Number 3 would be 7 to the 0 power equals 1. Number 5, when we're rewriting it, it is going to be 4 to the negative 2. Remember, the answer is always the exponent, so it's base 4. It's got a negative 2, and it's going to equal the 1 over 16. Now, when you get to problem 7, it wants us to go the reverse. They want you to create the log form. So we're going to say log. Now, what will it equal? It will equal the exponent, right? Well, what's our exponent? A 2. So it's going to equal the 2. The 14 that is the base becomes the base of the log, which turns kind of small. They write it small. And then the 196 comes here, and it's normal size. And that is how you rewrite it. It is 14 to the 2 equals 196. Look at number 9 with me. We're just only rewriting it. There's really you're not solving them. You're just rewriting them. So this one's going to say log. The base is 12 right here, isn't it? So the base of your log right here becomes that 12. 1 is your answer, because the answer to the log is the exponent. And then the other 12, this 12 here goes right next to the, kind of by the log word. So right inside there. And this is your answer to number 9. You rewrote it. What do you guys think about number 11? It's going to say log what? Little base 2. 1/8 equals negative 3. You got it. Okay. I want to pause for just a moment, and I want you guys to do the evens on this page 9. Okay. I'm trying to build a good foundation, so we'll do, I promise, as much as we can, but I want to teach you tricks. We'll do some of it today, but not all of it. Okay. Yeah, it has a lot of buttons, doesn't it? Okay. Hey guys, how are you doing? Are there any that are still working on the converting? No, y'all are fast. Okay. Then let's go over those answers and make sure everybody did get them right. Okay. So, if you will, go back. Let's see. Okay. Go back to problem 2. What will this one say? Okay, very good. 6 to the 3rd is 216. What about number 4? 2 to the 4th equals 16. Very good. 2 to the 4th is 16. What about number 8? 6. Very good. 9 to the 3 halves equals 27. What about number 8? Okay, now let's try to practice saying it the way they wanted us to. It's log base 3 of 81 is or equals 4. Are you guys okay? I want to practice saying it the real proper way to say it. So what would we say on number 10? Log. Okay, log base 36 of 1. Ooh, not 1. I just had a typo here. Of 6 equals 1/2. Very nice. Okay. And so again, it's log base 36 of 6 equals or is 1/2. Okay, that's the correct way to say it. Okay, last one on this page. What is it?
Log base 8 of 16 equals 4/3.
Very nice. And that is the correct way to say it and all. Good job. So we've completed all of page 9. Let's move to page 10. I want you guys to kind of read the statement at the top of page 10. So I'll give you a moment to kind of look that over. Then I want to ask you, do you recognize any of them in 13 through 20 that would be a common log? Number 15 is a common log. It says that a base that has 10 can be written without the base. So when you don't have a base number, it is automatically a 10. Something kind of cool about that is the calculator next to the 7 key, there's a log button. But this log button, anytime you press it, it automatically is doing base 10. It is only base 10 when you press this button, okay? But I'm going to teach you guys a trick. So I'll come back to the calculator in a moment. Let's talk about how we evaluate the logarithms, okay? So on problem number 13, evaluate is really solving the log. You want to solve it. What I start out teaching students is to rewrite it as an exponent. The way you solve logs is you write them as exponents. So in this first one, the exponent is the answer that we're trying to find. So I kind of put equals x. And if I rewrite it, it's going to be 7 to some x power is 49. And a lot of us can probably look at that and just tell the answer. What power of 7 makes the answer 49? 7 to the 2 power. Okay? 7 to the 7 means 7 sevens. We only need 2 sevens, right? 7 times 7 is 49. So be careful there, but the answer is 2. If you look at that problem 15, because they told us it's when you don't have a base that it's okay to put a 10 in, this one would be 10 to what power is 100. Well, isn't that also 2? 10 times 10 is 100. Okay, so this answer is also 2. But now I want to show you that calculator a minute. So go back over, and I'll clear it for a minute. I'm going to press the log button once, and then I'm going to press in the 100, and your calculator will work this. Notice it is also the answer 2. It will only do base 10s when you use that button, so be careful. Let's move on to number 17. Okay. This particular problem we would say is 2 to what power is the number 64? If you're not sure, today I've had a lot of common mistakes. A lot of students thought that it was 8, but that means 2 times 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 2. And if you do 8 2s, that is actually, I think, 256. Okay? So you may want to test it in your calculator and just plug in a few, and it is 6. Okay? So the answer to number 17 is 6. 2 to the 6th power is the answer 64. So 6 is the answer to that logarithm because the log is the exponent. We're looking for an exponent. In number 19, I when we rewrite it, it would be, and if you want to write the equals x, you can. It would be 9 to the x equals 1 over 81. Now, some students may not know what to do with this one. It's better maybe if you don't see the answer or know how to get it, that you do what we did yesterday. Remember how we can make the 81 go back to the top? By giving it a -1. You could kind of work this problem like we did yesterday. Then you can, 81 is 9 to the second. And then 2 times -1 is -2. So our answer is a -2 here. Some students might have been able to figure it out in their head, but that one is a little bit more challenging. I want to pause again for a moment, and I want you to work 14 through 20 at your desk. Make sure you're not trying to use your calculator to actually do them, that you're using your brain to do them. It is important that you know the steps, okay? It'll make you stronger for the next things that we do in our unit, okay? I promise to teach you the tricks later, okay? Right now, try really hard to do it by hand. Yes. Yeah. Yeah. That's exactly what we're doing. Okay, good job. Okay, let's take a moment and look at these. So looking at problem number 14, if we rewrite it, it's going to say 3 to some exponent is the answer 27. So we're trying to figure out the exponent. The log is the exponent. So when you evaluate a log, you're looking for the exponent that makes this true. So 3 to what power is 27? 3. 3 is our answer. Okay. For number 16, when you rewrite this, it's 12 to what power equals 1? It is a 0 power. Be very careful. I've had a lot of people that said the answer is 1, but 12 to the 1, if you plug it in, is really just 12. But if you do 12 to the 0, you'll see, hey, that's 1, and that's what we were looking for. So be careful on that one. Looking at number 18, 3 to what power is going to give 243? Now, when I did this one, I didn't remember all the powers of 3, so I just started 3 to the 4th. And then I did 3 to the 5th. And I kept doing them until I found them, and I think 3 to the 5th, that was it, isn't it? Yeah. So 5 was our answer. So I just went through and kind of used my calculator as a useful tool, okay, because I didn't know all the powers of 3. Now, if you guys look at 20, This one is 64 to some power makes 4. Now, this is a little bit strange to look at for thinking, is there a power of 64 that makes 4? Well, think about it like this. 64 to a 1 is 64. 64 to a 2 power. Oh, but we're trying to get small. So it's some kind of a decimal number. Do you guys see that? That it's not a whole number, because whole numbers are getting really big, and our answer here is really small. It's a 4. A way that I would do this problem, since we're trying to do them by hand, a method that I would probably do is I would change them to bases that match. Do you guys remember from yesterday how we made the big base numbers here match? And 64 happens to be 4 to the 3rd. And this 4 really has a 1 right here. And if I can make the bases look alike, then I can just equal the exponents. So if I equal the exponents and I solve that little equation, we would divide by 3. So the answer that we were looking for was 1/3. And now if you go in the calculator, it's kind of cool to check. You could do 64 raised to the 1/3 power, and it is 4. So you could check and kind of use your calculator as just a little helpful tool there. And now to move on to the last part of our lesson today, the change of base formula. It is what the name says. We are going to change the base. What base would be kind of cool to use? Which one is in our calculator? Oh, wouldn't it be nice if we could make them all base 10s? And then we could type in our calculator, yeah? That is what this formula does. It changes the base so that you can utilize your calculator. Notice up here on top, log A has no base number. That's because they made it a 10. And notice down bottom, it's log B has no little base number right there. It's because they turned it into 10s. So, but be careful. Notice they do log of the number A divided by log of the little base number. Okay. Now, so in problem 21, let's work this one together. In problem 21, when I write it, I'm going to do log of 64 divided by log of 16. But let me show this in our calculator, okay? I'm going to hit clear. In the calculator, I'll start out pressing the word log. I want you to see what happens on my screen. It opens a parenthesis right here. I'm going to press 64, but in order to do the math correctly, we want to close that parenthesis. So I'm going to close the parenthesis, which is above the 9 key. Then I need to press divide. And then I need log. So find that log again. And 16. Now notice on the 16, I can close it, or I don't have to do anything. I can just press enter. Enter will give us the answer, and the answer to that problem is 1.5. Also go back to the one we had some trouble with. Like, remember how that one may have given you, number 20 may have given you trouble? You could have said log of 4 over log 64. Let me just show log 4, remember to close it, divided by log 64, hit enter, and look, we said the answer was 1/3. Is 0.33333 still 1/3? Yeah. So your calculator can do change of base formula. And this is one thing that I'm trying to teach you guys today. I want to give you a few minutes to do the 22 to 26. So take a few more minutes and type these in your calculator.
Does the order matter?
You have to do the big number over the little one. Yeah. When you do the change of base. So in problem 22, you would have to do log 32 divided by log 8. Okay?
We're not rounding the points up or anything, right?
They just carried them out like 3 or 4 places. Okay? And the directions didn't really tell you where to round, so it really, I guess, didn't matter, but they carried them out several places.
I ran into the 10.
Okay. That's fine. Yes.
Is it always the bigger number that you just do on top?
Yes. Okay. All right. We're back, and let's check these answers. So when you do number 22, you do log of the 32 divided by log of the 8. Just always remember to close that top parenthesis before pressing the division. What answer did you guys get? 1.6, and I believe it repeated. That is correct for number 22. For number 23, when you type in your calculator, you should do log 54 divided by log 2. And what answer did you guys get? 5 point. Some of you said 8. They just wrote it out a little bit more. 5.7549 is what you should have seen. Okay. It's okay to round it off. The test, I'll put specifics. So on this page, it didn't really matter where you rounded because they didn't ask. For 24, I want to point out 24 is a common log, isn't it? See the base 10? Now we could do log 294 divided by log 10, which gives us 2.4683. But since it is a common log, couldn't we have just said log 294? And isn't this button the base 10 button? So log 294 and press enter. Isn't that the same answer? Oh, that one you could have done a shortcut because it's a base of 10, and base 10, you didn't really have to do the change of base formula. Okay. What about problem 25? It is log what? 136 over log 4, which is what answer? 3.54 is wonderful. If you wrote it out a little more, that's a little more of the answer. What about number 26? Log 1 over 36 divided by log 6 equals what? -2 was the answer. Did anybody have trouble putting that one in your calculator? The number 26? Okay. Just let me know if you have any questions. Your assignment is to complete page 11. But let me explain something on page 11. You are on the bottom part is where you're supposed to use your calculator, starting at problem 16. 16 and the bottom, that's really calculator. Above 16, the 7 through 15 section, you guys are really supposed to be able to do those by your brain and not typing it in the calculator. I'm telling you guys that so that you're prepared and have a good, strong foundation for this unit, for the other things that we're going to learn and talk about later on. I hope you guys have a great weekend. Remember, page 11 is your assignment. Mm-hmm.